one of these and a second one of these, or maybe you want to add one of these. This video is a version of the class that Steve taught at the Truck Camper Rally 2022. Now this isn't just for truck campers obviously, but anyone with a truck who is carrying or towing a camper. And if you're contemplating using an alternator solution as another charging option for your camper batteries, you may want to take a look at this. So in video 1, we broke this up into 2 parts. The class was quite long. So in part 1, Steve covers and explains how the alternators work, where they are most efficient to charge your battery, and how a smart alternator works or may not work for charging your battery, and explains why. And then in part 2, he will go through and cover a couple different solutions for using the truck's alternator as a charging source for your battery. And for us, this was a game changer last year. We had put in a second alternator. He'd actually upgraded it, and we were ready to test it. And it's a good thing everything worked well, because all of our solar panels died, and the alternator was the only way we could keep our batteries topped off until we came home and got the solar panels rectified, which is another video. I can post a link up above if you're interested in that. Anyways, take a look. If you have any questions or comments, please drop them down below. And next week we will push out part 2 of this video. Steve also is using the handout that he used in the class. It is on our website, WorkingOnExploring.com/techdocs. So take a look. This particular shop talk is slightly different because Steve's not here and in the shop, and you'll notice that right away as he takes it away from a hotel room.
Hello and welcome to Working on Exploring. Today we're going to talk about alternator charging of your auxiliary battery. There's a lot of misconception about what you can get from your vehicle. There's a lot of expectations about what you can get from your vehicle, and I'd like to try to bridge the gap. I'm going to cover how the vehicle is able to charge your RV. I'm going to talk about how your alternator works, what it's capable of doing. I want to talk about smart alternator systems and what they intend and what they provide. Then I want to talk about a few solutions to overcome the shortfalls. So that's what we're going to be talking about. I'm going to be using a handout that is available on my website, WorkingOnExploring.com/techdocs. If you go there, you'll find a alternator charging handout. So to get started, on the handout in the upper left-hand corner here, we have a representation of the significant components of the vehicle. We have an engine which has a 3-to-1 belt drive driving your alternator. In this case, I've chosen a 170 amp rated smart alternator. The smart alternator itself the alternator itself is not smart. The fact that it's connected to the engine control unit, and the engine control unit simply tells it what voltage to put out. That's the limit of its intelligence. The engine control unit is what the real intelligence is because it is plugged into the rest of the vehicle. We have an ignition system here which tells the system to come alive, and we have a starting battery here. In some cases you may have 2 starting batteries in your vehicle. With all smart alternators, you're going to have a current temperature and temperature sensor located on the negative post of the right next to the battery. There's a little box with a plug on it, a 3-wire plug typically. And things that have been added to the vehicle in order to provide charging for your auxiliary batteries in your RV are this split charge device, which will separate the battery systems when the vehicle turns off, and your deep cycle battery in your RV. To begin with, when you are talking about, and in this case I'm using 2 lead acid batteries. You may have a lead acid battery in your vehicle and a lithium battery in your car or in your RV, and we'll talk about some of those exceptions, but for the moment I'm going to try to keep it simple by saying you have a lead acid starting battery and a single lead acid deep cycle battery in your vehicle. And I'm going to represent here that one of the issues with charging batteries is that these batteries have different capacity to receive charge. And that capacity is measured by the internal resistance of the battery. In this particular case, your starting battery may be in the 25 to 50 milliohm range, and your deep cycle battery is going to be in the 50 to 100 milliohm range. The deep cycle battery has a higher resistance to charging than does a starting battery, and that is one of the very first hurdles that you have to deal with, is that your battery will not accept a charge as readily being in your camper and being of a different type. This split charge device, let's talk about this real briefly. This is something that you don't want to keep your starting battery and your camper battery connected together, because when you're consuming electric power from your deep cycle camper battery, you don't want to be drawing down your starting battery and prevent yourself from being able to start and leave in the morning. I'm not really going to talk about the split charge device. This is the common solution. The wiring system between your camper battery and the vehicle may be your trailer connector harness, or it may be a special application charging harness. In either case, you're never going to get very good charging through this system because the alternator will not assume that it's supposed to charge your camper battery, and literally it won't. And we'll talk about that in a few minutes. Let's go on from this point and talk about the alternator itself. All alternators have performance statistics, and those statistics are important. If you look at in the lower left-hand corner here, you'll see a alternator performance chart for a 170 amp rated capacity alternator. First thing you have to understand is what is the rated capacity and what does it mean? So this alternator is 170 amps rated, and what it means is that at 6,000 RPM we follow the purple line all the way up to the performance curve. This red solid line is the performance curve of the alternator. It starts generating power at about 1,500 alternator RPM. It ramps up fairly steeply, and by the time it gets to about 6,000 RPM, this is its rated capacity. It is not the maximum capacity, and it is not the continuous duty capacity. It is simply one point at which all alternators can be compared. In practical purposes, it's about the maximum capacity of the alternator that it can produce at any time for any reason into any supply. It very rarely is ever experienced, but if you were to connect a lithium-ion battery directly to the alternator, that is one experience that this alternator would be able to produce its maximum output, and it would do so for 10 or 15 minutes, and then it would burn out. So that is one thing you should not do. Let's look at the characteristics of the performance curve of the 170 amp alternator. So it starts charging at about 1,500 alternator RPM, which is about 500 engine RPM. And your engine idle zone is somewhere in the 650, 550 RPM area. And in that zone, the alternator has a fairly steep performance curve. It can produce anywhere from very little to about 30 to 40% of its rated capacity. And this zone right here is when the vehicle is first starting, and most of the power produced by the alternator while it's idling is being consumed by the engine and the vehicle systems. There's not much power available for charging an auxiliary battery when the idling is occurring. And then as the engine speed increases, you can see we climb up the curve, and we can have the capacity to produce more should any devices require some of that capacity. So one of the requirements would be our auxiliary battery. One of the questions is how much can we get from this battery, and how much will we get from this alternator, excuse me. One of the things that we have to consider is, although this 170 amp is its rated pretty much maximum power, what are we able to produce on a continuous duty basis? Meaning we might be able to produce one of these high amperage rates for a few minutes, but we can't produce it for hours, which is what a battery will need. So the red curve with a dashed line is a line that I applied on this curve. So this just for your information, this entire chart is a Ford produced chart. All the colored items on it are the red lines. The solid red line is overlaying a black line. I put it on there to highlight that line. All the black lines are performance curves that show what the operation efficiency of the alternator is. Most of you are probably assuming that you have a fairly efficient alternator. Well, very few engine alternators are very efficient. So at its most efficient point, somewhere in the 2,000 to 3,000 RPM range, when it's producing around 60 amps, that alternator can be about 75% efficient, but it all goes downhill from there. And as you can see, these growing circles, the faster the engine goes, the less efficient the alternator becomes, and a lot of heat is generated. The real performance curve of the alternator starts here at 0, goes up to about 55, 60 amps, and then it takes a much shallower curve. And this is a continuous duty line, which means this is its continuous output. This is not a peak output, not a one-time output. This is a continuous duty output. At low RPM, it can't put out a lot because the cooling power of the alternator is dependent upon the engine speed, because the fan inside the alternator draws only a certain amount of air, and the faster that fan goes, the more air it can consume. So as it goes faster and faster, it begins to consume more and more air. But eventually the inefficiency of the alternator increases, and there's so much heat being generated that the alternator starts to reduce its capacity. So this dashed line is the real capacity of the alternator that you need to understand. If you have a different alternator, the assumption will be that this continuous duty line is approximately 1/2 of the rated capacity of the alternator. If you use that as an assumption, you won't be very far off. No alternator manufacturers nor vehicle manufacturers actually specify the continuous duty capacity. Moving on, what alternator capacity is available for battery charging? This green box here ranges from about 30 amps to about 60 amps. And this is the power that the vehicle is going to need to draw from this alternator to operate. It needs probably around 30 amps just for the engine systems to operate, either a fuel injection systems, the engine fan, the spark plugs if it's a gasoline engine. All the equipment that the engine needs to operate is going to draw somewhere around the I'm talking about trucks here, pickup trucks, 1/2, 3/4 ton, 1 ton trucks, which have the capacity to move an RV. That's what we're talking about here. These are fairly large size vehicles, so they're going to, on a nice sunny day, you start the engine, you drive it down the road, it's going to draw about 30 amps. If it's a cold, dark day and you have to turn the headlights on, that's going to draw another 15 amps. If you turn your heating system on, it's going to draw another 10. If you're going to turn your seat heaters on, it's going to draw another 10 or 15. The vehicle has the demand ability to go from anywhere from about 30 to about 60 amps of capacity. Now remember, in this particular alternator, our maximum capacity is somewhere around 85 amps. So that tells us, this little yellow box here tells us that we have some available capacity that we could be using to charge our auxiliary battery, because that's what we want. We want to be able to use this extra capacity to charge our battery. So that capacity is going to range somewhere between 25 amps to 55 amps. Now, how do we know how much that is? Well, we're making a number of reasonable engineering approximations in order to arrive at that. Just so you know where I'm coming from on this, is my 2004 F350 with a 6-liter diesel engine. I have instrumented the 2 alternators on the vehicle, so I know exactly how much amperage and how much voltage they put out. I know what temperature they run at when they're putting those out, and I can also have a digital tablet on my dash that displays all my engine parameters. So I'm very in tune with all of the engine information that I'm portraying here, and I've used my system to extrapolate onto this 170 amp rated smart alternator approximate capacities. And so you can scale this to your own. If you've got a 200 amp or a 225 amp or a 250 amp alternator, you can assume that your vehicle draw is about the same, and your continuous duty capacity again is about half the capacity of your rated alternator rating. So in this particular case, we have some capacity to charge with. Now, notice that when I talked about this alternator capacity, I didn't specify whether this was a variable voltage alternator, a smart alternator, or a fixed voltage alternator. So the capacity of the alternator has nothing to do with the control system. So what we're now going to, so we can understand that, okay, we have some capacity here. We wanted that capacity. We want to be able to use that capacity. We'll get to how we can use that capacity. But first, we need to talk about how a smart alternator behaves in operation to understand whether that is a behavior that's going to be suited to our charging or not. Okay, so now I'm going to go over here into the bottom right-hand corner, and this is a General Motors graphic about their smart charge regulated voltage control strategy. And this is to say that, again, this smart alternator, it is more correctly termed a variable voltage alternator. As I've already explained, it itself is not smart. It simply takes commands from the engine control unit to output a different voltage. An older vehicle like mine has a fixed voltage alternator. My alternator puts out about 14.1 to 14.2 volts all the time. The smart alternators will put out a voltage anywhere from about 12.4 to about 15.5 volts under different circumstances, and each of those different circumstances has an effect on how it's going to charge your camper auxiliary battery. So let's get into explaining that. So I'm going to follow this blue line right here and explain the changes in alternator output voltage relative to what's happening in the automobile, because this is how a smart alternator works. So when you first start the engine, this small little low line here is that alternator voltage is going to stay at about 12.4 volts as the engine is just getting started. There's no reason to try to charge with the battery when you're drawing a lot of power from it to run the starter. So the alternator will literally remain off until the engine starts, and as soon as it starts, the alternator will ramp up over a period of maybe 10 to 15 seconds to produce 15.5 volts in an attempt to restore all of the power withdrawn from the battery during the charging cycle. Okay, so it's going to keep that and it also might idle up the engine above the engine idle RPM of 500 to 600 RPM. It might idle it up some, especially if it's cold outside. So but that alternator is going to produce 15.5 volts in an attempt to restore the charge to the battery that was consumed in starting the vehicle. As soon as you put it into gear and begin driving, that voltage is going to drop off because your engine RPM is low. You're just starting to drive. They don't want any undue loads on the engine that's cold that might cause it to run roughly. As you're driving out of your driveway to your local stop sign, the voltage on that alternator is going to stay relatively low, and then when you reach some reasonable driving speed, the voltage is going to ramp back up to a 15.5 again to try to restore the charging deficit from starting, and it's only going to restore about 80% of that deficit. The Smart Alternator wants to guarantee that there is some deficit remaining in the battery, and I'll explain that in a moment why that's necessary, but you need to have a place to push power into, and that's the reason for it. So what's going to happen is that as it's restored a majority of the starting charge, the battery voltage is going to drop back down here to a low voltage of somewhere between 12.4 and 13 volts. At that voltage, a 12-volt battery will not charge. And that is exactly the objective. That 12.4 to 13 volts is enough to operate equipment in the vehicle, but not enough to charge the battery. The entire purpose of a Smart Alternator is to improve fuel economy in the engine. And it does so by following a variable voltage profile and doing different things at different times to the old alternators would produce a constant voltage and a lot of energy that was oftentimes in excess of what was needed by the vehicle. So in order to save fuel, the Smart Alternators are going to try to be a little bit more wise in their production of electric power. This is the first 5 minutes or so of the starting and operation of the vehicle. Let's drop down to the red line here now for a minute. So if you were to again start your engine when it was hot, it would go through a somewhat similar situation. The voltage is, instead of being 15.5 going into a cold alternator, into a cold battery, is going to drop down a little bit, and then again the same thing is going to happen. It's going to drop to this float voltage of about 13 volts. Here's where the key really comes in of what a Smart Alternator is all about, and this little bump in here demonstrates it. When you are driving along and your engine is just producing just enough voltage for your systems to operate, any rapid draws in power on the engine system are going to be fulfilled by the battery. The Smart Alternator purposely keeps the battery partially discharged while you're driving, and the purpose is that when you step on the brake, when you're coming up to a stop sign, you take your foot off the gas, you step on the brake. As soon as you touch the brake, the voltage in the alternator is going to go from 13 volts up to right back up to 15.5 to 16 volts. And this is why that you have a very large alternator, is to try to push as much energy into the battery in a very short period of time as possible. This energy is into heat by the brakes, but if the engine can make use of this energy by slowing the vehicle and pushing that energy back into the battery, that energy can be saved. And that is one of the methods that it uses to reduce the fuel consumption of the vehicle. Different motor manufacturers have different modes of operation for the Smart Alternator systems. There are anywhere from about 8 to about 13 different modes, and some of these are helpful to us in charging our auxiliary battery. If you're driving down the road and you need air conditioning or heat, air conditioners and heaters don't work very well with a 13 volt or anywhere from 12.4 to 13 volt electrical system capacity. They need something more to spin that fan a little faster and to get air moving. So if you turn your air conditioner on, the system voltage will move up to about 13.4, 13.5 volts. You're now getting into the neighborhood of what may charge a battery, but even at that higher voltage, very little battery charging will occur. And most of the time your vehicle will spend in a voltage level of somewhere between 12.4 and 13.4 volts, and at no time will any of this provide any significant charging to your RV battery. We've talked about what the alternator is capable of. We've talked about how the Smart Alternator behaves in its variable voltage operation. None of these are particularly helpful as the vehicle is built in order to charge an auxiliary battery. The Smart Alternator keeps the operating voltage too low to produce any effective charge, and that's what the first thing you need to take away from this thing. So let's look up here my little list of pros and cons. So if you have a system like this to try to charge your battery, the things you like about it: it's simple, it's inexpensive, very little needs to be done in order to install it. And one of the things that happens is by having these two batteries connected by a split charge device, oftentimes in an RV you have a jump or a boost switch near the driver's steering column, which if the starting battery is discharged, you can connect these two batteries and it will help you to start you can jump start your vehicle with your camper battery. Okay, so those are the pros. The cons of it is that this long cabling and the fact that these are different types of batteries means there's a very low charging rate. There is no control over the charging. This is an unintelligent charging system. And because it charges your battery poorly, your auxiliary battery poorly, it will lead to early demise of an RV battery if it's not well charged. As we've looked at in the case here, the charging capacity is somewhere between 25 and 50 amps. If you were to actually try to charge a battery with this system, you might get about 10 amps of charge into a lead-acid battery, but you'd get about 100 amps of charge into a lithium iron phosphate battery. And so the problems here is 10 amps of charge is too little to really do much in a lead-acid battery, and 100 amps charge is way too much. It's going to overload and burn out your alternator. So this is not a very good system to achieve what we're trying to achieve.
So that's the end of part 1. Next week we will have part 2 ready to go, so you can check out some more information on different dual alternator charging scenarios and what might work best for you. So hopefully you'll join us again, and thank you for watching.